Thanks everybody for joining the webinar today, making time out of your busy day. Hope you're using the lunch hour, or if you're in a not Eastern time, the morning hour to make this time valuable for you. We hope to be able to provide you with some insights on AWS OpenSearch, some different use cases for a few different industries. Definitely excited to talk to you guys. My name is John Aguilar. I'm our sales manager here at ITTStar. We're an AWS advanced partner based out of Atlanta, Georgia. And we're excited to bring today's topic to the table for you. I've got a few different presenters that I'm going to be introducing throughout the course of today's session. So let's get right to it. First up is going to be Chris Turner. He's a partner solutions architect covering data analytics at AWS. And then from the ITTStar team, we're going to have a joint presentation from Ajit St. George, one of our lead data engineers here at ITTStar, and Prithvi Kumar Reddy, who's one of our technical project managers on the data engineering and analytics team. So before we get started, I know you guys want to get to the meat of today's webinar and really learn something. I'd be doing you a disservice to not tell you a little bit about ITTStar and why we're qualified to kind of give you the tips and tricks and hints on what makes OpenSearch so valuable, as well as other AWS tools. So I want to share 2 or 3 slides here real quick about ITTStar, about who we are as a partner, and what our background is, okay? So give me just a moment. I'm going to bring up a brief introduction to who we are, give you some details there. So want to give you a view of our global scale as an advanced consulting partner. We are located around the world with our headquarters here in Atlanta, Georgia, our West Coast sales office in Phoenix, Arizona, our development center in Bangalore, India, and then delivery resources kind of scattered among the nearshore and offshore and even European countries. So we got about 110, 120 delivery team members on the team today, and we specialize in an abundance of different areas that you can see here on the right, whether that's from cloud infrastructure and hardware and data center migrations to AWS, application modernization and development projects or desires from our customers, business intelligence and analytics projects, building out data lakes and warehouses and modern data platforms, incorporating data science, AI, and machine learning tools on AWS, as well as modernizing databases and database strategies for our customers. A lot of our customers are engaging us on topics like today's topic when it comes to data analytics and how to take data analytics and data platforms that have been built or they've built over the last few years and incorporating some of these new cutting edge leading technologies on the AI, generative AI and machine learning side of the house. So we're excited to talk to you about that today. Other areas of service we offer, we do have a 24/7 NOC, SOC, and managed services operation. I'm going to cover some of that today, as well as business processes and kind of IT staffing and staff augmentation as well that most partners are going to be able to bring to the table. Our area of specialty really resides in that data area, that big data and analytics and data science area. So excited to talk to all of you about it today. But if any of these other areas of expertise are things that are on your business's slate for 2024, we'd love to talk to you about our expertise in those areas and what our background looks like. So just a little bit more detail into some of these areas of service. When I say we have a managed services team and a 24/7 NOC, SOC, and support team, we don't just cover cloud infrastructure, kind of standard uptime monitoring and alerting for underlying cloud infrastructure. We also have an application managed services team, an enterprise development managed services team, a database operations and data pipeline and platform operations team to assist with all of your database ETL, data cleansing, data analysis, data modeling, all of those types of needs. So would love to talk to you guys about those potentially at a later date. I know that's not why you're here today. So other areas where we specialize, building out those data warehouses, data lakes, understanding serverless infrastructure, building out intelligent applications, leveraging modern application coding skill sets, as well as incorporating AI tools into application builds themselves. These are all areas where our teams kind of combine their skills and their practices to ensure our customers get the best delivery possible, as well as the DevOps team that can help our customers build out CI/CD best practices, build out CI/CD pipelines, incorporate security steps and protocols throughout the DevOps process. Those are all areas where our customers today in 2024 are asking a lot of questions and having a lot of needs. So again, happy to talk to all of you about these things. Just wanted to give you a semblance of where ITTStar's background is as an advanced partner and what kind of things we can bring to the table for AWS customers to solve problems and attack challenges that they're seeing. So I'm going to leave it at that for the general introduction for ITTStar, just in a nutshell, who we are, what we do. And I'm going to hand over the microphone to Chris Turner from AWS. Again, Chris is going to kick us off here when it comes to OpenSearch, what it can do, and how it can help businesses. So Chris, if you want to go ahead and take the mic and run away with it, that'd be great. Thank you all for being here.
Thank you, John. So today I'm going to cover what's new with Amazon OpenSearch. So overall, Amazon OpenSearch is a fork of Elasticsearch. And now we have a managed instance within AWS. So with that, there's a lot of benefits that I'll cover and also go through some new features and enhancements that we have, cover overall a sense of what is OpenSearch, and then also cover some of the ingestion pipeline features that we have for observability. So overall, OpenSearch, like I said before, is a managed instance that we have in AWS. So one of the main features of OpenSearch within AWS is utilizing the advanced search capability of it, also performing various analytics for several use cases from observability, cyber, even Gen AI, and then also integration. So now OpenSearch, with the new features that we have within AWS, we can centralize a lot of the logging, and then you're able to search upon that, in real time and do other customizations and visualizations with that data as well. So say data coming from Kinesis, data coming from CloudWatch, S3, able to centralize all that within AWS OpenSearch, and then output various use cases, and then cost effective. So there's various mechanisms that we have to date to make OpenSearch very cost effective for you. Reserve instances, special tuning for instances against the types of nodes that you have in certain sizing. Also, we have OpenSearch serverless, but all those I'll cover later on as far as cost optimized new features that we have. So real quick, this is a listing of customers that we have to date. Of course, we have more, but this is just a listing that we have of customers utilizing OpenSearch. So various use cases across the board, petabytes of data that they are ingesting within the service, all to output various use cases with from Gen AI to advanced search capability with observability, from cyber use cases. I mean, you name it. So one customer case study I want to mention here. This customer had large volumes of data, up to 300 terabytes of data per day. I've personally seen more, but specifically with this case study, and they were centralizing all that data from various Kinesis data streams into OpenSearch. And because the way OpenSearch is set up, it can handle all that data at a sub-second level. So as the data comes in, it is ingested into the nodes of the instance, and then you're able to search upon it and build whatever use case you want. Like I said, the use cases grow. We've seen larger than this, and then you're also able to customize your cluster or have various clusters per different use cases that you may have, all within your one centralized AWS console. So the two services to the right are new services that we have within AWS that are new launches that are added to our suite of services. So dashboards, and of course the OpenSearch service was there, but now we have OpenSearch ingestion and then OpenSearch serverless. And I'll speak more about those in a little bit. So the landscape of pretty much getting data within OpenSearch is similar to any other search application. You have documents, you have logs, you have transactional systems, all to be shipped with some sort of ETL pipeline for the most part to normalize that information, do some sort of enrichment, and then send over to OpenSearch. And then these are some of the personas that utilize search engineer, DevOps, platform engineer, but also to include analysts that just want to view the dashboards and see the relevant information displayed, and also just general consumers, because once that data is in there, that large corpus of petabytes of information, you can output just visualizations, dashboards, in real time. So what's new? So just cover all the new features that we have, especially around the ones that are specific to observability. So our new OR1 optimized instance family, it's pretty much the best bang for the buck that you can get with an instance. So improves your throughput, it improves your price point. Of course, it's durable. Another update that we have is how we manage our cluster, and say if you want to spin up your cluster or migrate to another instance, that's available as well behind the instance family that is being launched, to all have a very robust environment within cloud. So you don't have to worry about your cloud, you losing data, or your cloud, or losing replication, because everything is managed within AWS. So also, this is a new feature. So with the explosion of ChatGPT and Gen AI and these other large language models, OpenSearch, along with the observability piece of it and utilizing the abilities of just searching on data as a data store, you can use OpenSearch to build upon a chatbot application. So this is just a simple example of doing that, but it just shows you the capability of OpenSearch that we have. And then also, this is in our serverless offering as well. So where this is apparent within serverless is we have a client that has a provision instance utilizing a provisioned observability cluster, and then they want to spin up a R&D instance of a chatbot. They want to utilize generative AI for X use case. So they can do that with our serverless instance, and the price point is very well structured to only utilize the vector engine for data they consume and then data they process based on our compute unit model. So you can designate your environment, but still all within the same console, very easily able to read and track these different domains. So this is another new feature that we have, is integrations. So integrations at high levels, making it easier to integrate your SageMaker capabilities within your environment, and basically extend that gap to getting machine learning, filling the gap between your machine learning capabilities to OpenSearch. So these integration templates will grow. We're also looking to add in like ISV partners or other partners to include their integrations as well. So this is a brand new feature that launched in 2.11. And we're just looking to grow the ecosystem of integration templates that can do some of the capabilities that is outlined to the left there. So OpenSearch ingestion. So this is a really, really cool service. This is actually one of my favorite that launched. So it's powered by data preppers. So one of the big issues that are around in observability cyber use cases, really anything that revolves around shipping data to a search utility, is how do I know my data hasn't been dropped? How do I verify that my data being sent is still in OpenSearch? So this at a high level essentially tracks from start to finish the data pipeline, and then it's able to define a trace to see that information of you're getting the source data to this instance. And then in the event your data volume goes up, so say your source data destination is, there's a spike in volume all of a sudden, it goes from 1 terabyte to 10 terabytes, this ingestion feature is able to spin up the compute units to be able to adhere to that. And then also you can do a lot of filtering and processing within the ingestion service itself before it gets to OpenSearch. So say if you have a data source with 10 keys, key value pairs, and you only want to keep 2 of those key value pairs, you could easily do that with data prepper and before the data gets to OpenSearch. So you save on the data being indexed that goes into the system, and then also you're able to manipulate and normalize that data before it gets to OpenSearch. So say if you have a search utility using the pipe delimited processing or any other search app that you have within OpenSearch, you can easily search on the data, more easily search on the data, because it's already been normalized using data prepper. And then, like I said, the benefit is buffering and then also tracking that the data is still, present from source to finish. So another integration feature that we have is integration with S3, so zero ETL. So zero ETL at a high level is ability to look at data in S3 from OpenSearch. So you're not indexing this data into OpenSearch, you're just viewing it. So say if you have, say a cyber use case, this is very popular. You have data coming in, say from networking logs from different devices, from endpoints from all around the country. And then you want to bump that information up, align it against threat information in an S3 bucket, but you don't need to index that threat data. You just need to do a lookup, some sort of comparison to enrich the body of data that you have for your visualization. Now you can do this with S3. So you're not indexing this information. You're simply calling it from S3 and then being able to search on it and manipulate it with the data that's in OpenSearch. So another feature we have is zero ETL with DynamoDB. So this is able to essentially at a high level take DynamoDB data and stream it over to OpenSearch. So when data goes from DynamoDB, you essentially can stream it into OpenSearch, index that data, and build build embeddings for semantic search. You can automatically, build your own search application from your DynamoDB database. The list goes on. So essentially that data is mirrored over and streamed over, and then, you can build whatever search utility and or observability platform product you would want. So here is an example of just one example of the zero ETL with S3. So as you see, you have secondary data within S3, and then you have your primary data within OpenSearch. And then so if you search from right to left, the primary data is there, and then you're bumping that against the secondary data, but the secondary data stays over in S3. You're just making the comparison about your application against WAF logs, against VPC flow logs. Now I can see my CloudTrail logs, and I can identify, okay, these CloudTrail logs are doing this, and then it aligns to VPC flow logs that's in S3. So this greatly saves on cost because you don't have to index data in OpenSearch, and it also allows you to expand your ecosystem, data that you can search upon within OpenSearch. OpenSearch serverless. So as I mentioned before, serverless is a new feature that we have that you don't have to provision an instance. So everything's still in cloud, everything's still within AWS, but serverless allows you the ability to just send data to it and it starts working. So you pay for what you use, it's fast, it's easy to administer. So going back to the example with GenAI, if you want to test the GenAI use case out, you can just spin up serverless, send data to it, and vectorize your embeddings right there without having to worry about a provision cluster or even disrupting the cluster you want. Because a lot of times we see, they have a, say, observability platform searching petabytes of data, terabytes of data. They don't want to disrupt that. They don't want to mess with it. So spin up serverless is a good, easy UAT instance you could use, or you could still use it for production because, you could still productionalize, that type of information as well. OpenSearch Assistant. So right now, this is on the pipeline. This is a really good tool for observability. So at a high level, essentially you can use natural language processing to summarize the text you would want to search upon, as you see in the picture, and then it outputs a search for you. So I want to find this error within this corpus of data, or I want to find this error in this indice, and then it produces the search that you need. So this is great because it allows non-technical users to be able to search upon data and find information as they need. So an example would be auditors that need to search upon information within OpenSearch to output a audit finding based on some data set. They're not that technical a lot of times, but they would, need to use the data within to output that information. So they can easily just say, I want to find this. It gives a search, they run it, and outputs the tabular table of what they need to find. And then, of course, all the other elements associated to it. So that's just the start of it. But, this would only improve and get better as this new type of fundamentals of using this natural language within OpenSearch will, just only expand. So security analytics with OpenSearch, this is also a new tool, a new plugin that we have where it came out in 2.7 and then it's there now, on forward. So now we're on 2.11. So this essentially is our aim to how do we take security information, security data within OpenSearch, and and how do we align this to what would be closely resembled a SIEM, a SIEM, a security information management platform. So, I want to take these security data sets and also to add these, or also to include these can include non-AWS data sets. So like Windows event logs. I want to take these security materials, send it to the security analytics plugin. It will normalize the data for you to the new open security framework, and then also correlate your findings in real time. So it's the rules engine that is behind this is just growing. So the easy thing about it is you just send data and then it finds your correlations, and then you define your alerts, per need, but you just define the data in the rules engine, just will only grow and grow and grow. Also, you can add your own rules. You can add your own customized, notification rules as well. But just know that out of the box, it's only going to be it's a robust rules engine to anomalize security findings. So going back to OpenSearch ingestion, I want to show this example. So this is a general tech stack that we have with OpenSearch. So you have data from some sort of collection, and there's some sort of buffer, and then there's some sort of transformation, and then it goes to OpenSearch. So with OpenSearch ingestion, it can minimize a lot of that. These are also very, very amazing tools to use. Like Kafka, we have MSK, there's Flink, Spark. We have a lot of these managed tools as well. Lambda, I use Lambda personally all the time. Firehose, I love Firehose. but using OpenSearch ingestion, it minimizes the need for that a lot of times. And then also you have the buffering, the tracing, and those like observability elements as well. So like I said, you can still use this, but this allows you to minimize that footprint and to use a tech stack within the OpenSearch family for sourcing data to get data into your index. And then of course, once data is in OpenSearch, you can attach these other visualizations as well, like Prometheus and Grafana, which are very popular for people to use if they want to use it. You don't have to, but that ability is there. So this is just a summary about all the new features that we have within OpenSearch, from Gen AI, from Zero ETL. Zero ETL is only going to grow. The new OR1 instance families, to simplify it, you have all the best bang for the buck when it comes to instances, save money and increase performance. So a lot of new things coming this year, and a lot you'll see more in the future, especially this year around generative AI. And then that will also assist your observability use cases, your security use cases, and even your advanced search use cases. So also, last thing I want to add, this is the query assistant that anybody can access. Here's the QR for it. This is not a managed instance of OpenSearch. This will take you to the community version of OpenSearch. I'm sorry, the community version of OpenSearch Playground. And then you're able to actually see this stuff in real time, see more videos on it. Also, the OpenSearch service team, Amazon OpenSearch service team, has a lot of contributions to the community as well. So definitely take a look, and you can even play around with the data set as well. And here's my contact information. So thank you very much. And back to you, John.
Awesome. Thanks so much, Chris. And if anybody has any questions for Chris, we're going to have a Q&A session toward the end. So feel free to throw your questions in the chat. And if we have the time to address them, we'll definitely address them. And if not, we'll make sure you guys get a response via email or follow-up. Okay, cool. Next up is Prithvi and George to walk through some industry use cases, I believe. So Prithvi, George, it's up to you, fellas. Take it away.
Thank you, John. Chris, a big thank you for sharing your insights on OpenSearch and its features. At ITTStar, we've been heavily involved in OpenSearch and centralized log analytics for our customers. And today, we're excited to dive into some detailed project case studies that ITTStar has implemented, particularly in the finance and retail sectors. We also will be discussing how these industries have been benefited from the capabilities of OpenSearch. Joining us is George, the lead data engineer behind these projects. He has developed solutions that have truly made a difference for our customers. We will maintain our discussion in a conversational manner to provide a deeper analysis of a specific case studies that we have been worked on. Hey, George, great to have you here today.
Thank you for the warm welcome, Prithvi, and good morning, everyone. It's truly an honor to be here with all of you today. I'm Ajink George, and I'm delighted to serve you as a speaker for this webinar. In our time together, we'll be diving into some of the capabilities that OpenSearch provides. This is a subject that I am deeply passionate about, and I believe it holds tremendous value for all of us today in the data industry. So for today's agenda is we'll be driving through some of the industry solutions, and then we'll explore some of the searching and streaming capabilities of OpenSearch. And then I'll showcase some of the services or the ingestion flow that we do regularly in ITTStar. And I'm also explaining two of the case studies that we have did for two of our clients. And we have prepared a small demo for you guys. And then we'll move to a Q&A session, which will be to the end, like 5 to 10 minutes. And talking about OpenSearch itself, so it is designed to provide scalable and performant search capabilities for broad range of applications and use cases. So with OpenSearch, developers can efficiently index and search huge amounts of structured and unstructured data in real time. So it enables users to find the information they need quickly and accurately. So that's like a basic intro or something that we have to look into for OpenSearch with the capabilities and advantages that OpenSearch provides.
Hey, Jinxon. So you've been working extensively on OpenSearch and its centralized log analytics. Could you share some insights into its use cases?
Sure, Priti. So I was coming to that. So talking about the use cases of OpenSearch itself, so it integrates with other AWS services So it allows us to design comprehensive cloud-based search solutions. Some of them are like functionality with websites. So we can have a log data analytics, and we also have a personalized recommendations. So if you come to the use cases in depth, so we can see like we have multiple use cases with OpenSearch itself. So we have a seamless personalized search capabilities with OpenSearch, which we can use, where we can use for our fast search experience for applications. And also we have we can use with the websites, we can use with the data within our data lakes, and we can also use that with users to find relevant data quickly. And coming up to the security functionality for OpenSearch, we can use it for quick detection of security incidents. So it's say like if there is like we want to analyze real-time data and give back quick response, we can use OpenSearch for real-time analytics. And also you can use this within forensic analysis and use it for real-time responses for particular areas that's coming in. Then
Thanks for shedding
we
some light on security aspects. So security is super important, but especially for the healthcare with sensitive data, right? So can you tell us like how OpenSearch keep this data safe, like both when it's stored and when it's moving around, and how would this help a healthcare organization?
Yeah, sure, Priti. So not only for healthcare organizations, so like some applications like e-commerce, healthcare. So overall, within the industry itself, so the data can be stored in a data lake, a centralized repository, and used within OpenSearch. So it has its own encryption capabilities and has role-based access control mechanisms, which can ensure that sensitive data remains confidential and secure. So as you may know that healthcare organizations follow some of the HIPAA regulations. So they follow certain policies and standards, and OpenSearch can come up to mark ensuring that the data is secure. So I think I hope like I answered your question, Prithvi. So
Absolutely,
OpenSearch is the
George.
best solution for that. And
Yeah,
yeah, coming up to the next use case that we can implement OpenSearch is for the infrastructure monitoring, where we can use it with several applications or devices such as servers, routers, switches. So these can be used for data that's for metric that's being collected. We can use these service with these services and get all the data consolidated in a centralized repository and use it for our trace analytics or secure analytics with the OpenSearch itself. And we can use the OpenSearch platform for observing platforms. So we have monitoring features specifically provided by OpenSearch itself. So in order to analyze the real-time data that's coming in, we can have real-time analytics done with it. Like let's say if there is an IoT data that's coming in or a logs that's coming in from different platforms, we can have the data monitored within the OpenSearch itself, which has notification features and it gives real-time notifications or emails so that we can respond back immediately. So these are some of the use cases that we have for OpenSearch. And if we talk about the real world scenarios or in the today's industry with the data, where we can apply these applications are like some of them are like a personalized search or seamless search using within the data. You can use OpenSearch. So let's say if it's a website search, let's say like if we are trying to analyze how many people came to a website and how many people are trying to use a product, and we need to analyze the data. Or let's say if we have a multiple website of the same organization, so we want to analyze how many customers are using the website or the newsletters, how many people are coming in and going out. So if you want to track all that data in a consolidated manner, we can use OpenSearch. Or there is another application where we can use these to analyze for application data that's coming in, where so we have a service-based industry where multiple service-based logs come in and we want to analyze them. We can use OpenSearch to tool for analyzing all this data. So also there are like multiple applications like semantic search, retrieval and augmentation generation. So this is all applicable in OpenSearch. And there is what we have specialized in is the centralized log analytics, where we collect data from multiple sources and we analyze them within OpenSearch. So that's one of the main features that OpenSearch provides. And the extra capabilities that OpenSearch can provide is that trace analytics and log analytics. And it also provides anomaly detection, where we can in-depth analyze errors that's coming in, and we can tackle the error and pinpoint them based on our needs, and we can take appropriate actions based on the service itself, so that we don't need to depend on any other external device or external service itself. It's all included within OpenSearch.
So, George, when it comes to implementing personalized search, I'm sure that there are a lot of hurdles. So, what are some common challenges that you have faced in your experience, and how does OpenSearch come to rescue and tackling them?
Yeah, good question, Prithvi. So while we were solving, or when customers come to us and when we are trying to make solutions for their issues, so we have faced several challenges, and the main challenge that we face during this is relevance and precision. So the personalized search needs to buy the data, like if you want to understand the user's intent, and if we want to deliver the accurate results. That was the main challenge that we faced, and OpenSearch was the solution that we have provided. So the robust query capabilities and scoring mechanisms that can be fine-tuned for relevance, and we can also use custom analysis and filter for enhanced precision. And one of the other challenges we faced during our solutioning was adapting to the changing user behavior. So OpenSearch analytics and visualization tools and its capabilities with the machine learning libraries enabled us to analyze the user's behavior and used it for continuous improvement. So those were some of the challenges that we faced during our solutioning with OpenSearch. And like OpenSearch gave us like in-depth understanding of how we can solve these problems appropriately in a good manner. So
It's
the
amazing to learn how OpenSearch can tackle such challenges in personalized search. This makes it simpler to give our users the customized results.
Yeah, sure. So those were the use cases, and talking about the advantages that OpenSearch provides are these are some of the main advantages. So we have unified view, scalable service, and predictive insights. So talking about them, like if we have like challenges, or like we have desperate logs that we want to predict accurately, or if the data is being scattered across different sources, we can have a consolidated view of the data within a data lake or a data warehouse using OpenSearch, and we can use it within the clusters to analyze the data appropriately. And talking about the scalability features, so like in today's world, when we are trying to analyze the data, due to the overloading like data that's coming in real time, there can be throttles or there can be issues with analyzing the data itself. So OpenSearch with its scalable features, it's very effective to analyze the data, and it's multiple advantages, like it's cost effective and it's secure while analyzing and transiting the data in and out of OpenSearch cluster itself. And it also provides machine learning integrations where we can use anomaly detection for analyzing errors while we are implementing our solution within OpenSearch. So we have predictive and operational analytics, which OpenSearch provides with us.
So now let's talk about scalability. Imagine, okay, I know that you would have been working with e-commerce platform or some other different industries, but for particularly if at all we take an e-commerce platform, right? So that sees like a massive influx of data day to day. So how does OpenSearch handle that indexing large volumes of data efficiently, and more importantly, okay, how could this efficiently benefit a customer facing rapid data growth like the e-commerce platform?
Yeah, sure. So OpenSearch has distributed indexing capabilities. So it allows an e-commerce platform to identify and efficiently index large product catalogs. And it also ensures the new items are quickly searchable by improving customer experience. And also it provides up-to-date search results. So those are like some of the capabilities that OpenSearch itself provides
Yeah,
with the scalable features.
Yes, scalability is super important for any growing business, right? But I understood that OpenSearch can really help any e-commerce platform or any other industry to handle all the extra data as it grows. I have one more question, like keeping an eye on the health and performance of the cluster, that is very crucial for the smooth operations. Can you walk us through the tools and mechanisms that OpenSearch provides for monitoring the cluster health and performance? And how do these tools help in maintaining this overall health of the system?
Yeah, sure, Prati. So OpenSearch has a built-in monitoring and logging features,
Mhm.
and it enables a cloud service provider to proactively monitor cluster health and performance. So we can use these features to identify and address issues before the impact itself. So we don't need to depend on any third-party tools on any other services other than OpenSearch itself to monitor the data or monitor the system itself. So it has its own built-in features for that. So yeah, that's like a real good advantage of using the service itself.
Okay, knowing that OpenSearch provides that extensive solutions for keeping the cluster health is reassuring really. Thanks for highlighting the importance of monitoring tools.
Yeah, sure, Pratik, no problem. So coming up to the this is log ingestion flows or some of the services that we use within ITTStar. As you can see, we have like three primary stages. So what's the first stage is like the storage where we have multiple data lakes or data warehouses which we use for our day-to-day data storage or centralized log analytics. So some of the services that we use are Amazon Simple Storage Service, and like there is a Amazon Relational Database Service or DynamoDB, and there are like multiple services that we can use within the Amazon, like AWS itself. And then we have the forwarders where we use commonly we use AWS Lambda, and we can have database migration services, or we can have a customer application used for forwarding the data from the data lakes to the OpenSearch service itself. So these are some of the services that we can use for our purpose of ETL pipelining. And now we will go for some of the use cases or some of the case studies that we have used. So the first case study that we have is one of the hotel franchises where they were facing some major challenges for their log management system. So what happened was they were having multiple Wi-Fi controllers. So they were basically a franchise all over the world, and they were trying to analyze the log data and uh, uh, like impactfully get a result from that. Like, so basically, they were trying to analyze the quality of the customer experience, if it's good, bad, or average, and also they were trying to analyze the Wi-Fi controllers, see if it's faulty or not faulty based on the data that they are receiving. So we have used some parameters like session times, throughputs, signal strength, and based on this data, we were trying to give an output on how we can analyze the data itself. So basically, some of the challenges they had was the log fragmentation, because since uh, the franchise, like because of the franchise's multiple locations, they were not able to centralize the data in one particular location. So it was difficult for them to monitor it. And also because of that issue, there was insufficient analysis of the data. So like they were not able to tackle the issues at appropriate times. And due to the increasing data that's coming in daily, they were not able to handle the data. So there were also scalability issues that they were facing each day. So the solution that we provided for them was OpenSearch. So this is a general architecture, overall architecture that we have provided for the customer itself. So as you can see here, we have connected an IoT core, AWS IoT core service with all the IoT devices which we pull data from. And we have successfully stored the data and created a centralized log data within Amazon S3. So from there, we have used an event triggered program where an Amazon SQS queue pull the data to the AWS Lambda service itself. From there, it got uploaded to the OpenSearch cluster. So as you can see here, there are like new features, as Chris mentioned. You can have the third and fourth stage overthrown using an OpenSearch ingestion, where you can directly take the data from Amazon S3 to the OpenSearch. So that's like in recent release from AWS. So this is the overall solution that we have provided for the customer.
Now, talking about the another critical aspect, right? Like handling the high amount of logging workloads. So, what are some best practices or recommended approach you would suggest for configuring the OpenSearch to maintain the optimal performance and scalability in such scenarios?
Yeah, so for having the best performance while transferring the data, so if you're talking about the bulk loading of or large amount of data that's coming in, so we have for several best practices that we follow within ITTStar. So a major one is index sharding. So we break our data into shards to distribute across nodes. So this allows for parallel processing and improved search performance. So we need to adjust the number of shards based on the overall expected data volume. And one other feature is optimizing the shard size. So it can be too small or it can be too large. So a shard size is, if it's too small, it can create overheads. And if it's too large, it can impact the performance during the large searches. And also we can have other effective ways to control it, like we can have a few hardware considerations. We can have node and cluster monitoring, and we can also have regular updates for the OpenSearch itself. And let's also creating a backup and recovery feature all can help us, because if there is any data loss, we don't want to go do the same process. We can have a backup and get the data fast. So those are some of the ways that we follow in ITT stars to have the best performance while we are loading data from the source to the cluster itself.
Great insights, George. Just one more thing, like I see that okay, the logs coming from the IoT might be in JSON format, assuming that. So logs often come in various formats, right? So could you just walk us through like how OpenSearch manages and parses these logs with varying the structures and the formats?
Yeah, sure, Priti. So, as you mentioned, like, yeah, that's a good question, because we have multiple data coming from different sources. So IoT devices can have different versions or different companies. So the format that the data come in are different. So we had to like clean it and transform it based on our needs. So we had like a pattern followed. So in order to get to that point, we had used several methods, and so one of them are ingest nodes. So like OpenSearch has an ingest node that allows you to pre-process documents before indexing. So this is particularly useful for transforming logs into common formats. So you can define pipelines to pre-process or to perform various actions like grok parsing or date parsing and enriching data. And one other thing we can use is a dynamic mapping or dynamic indexing. So OpenSearch supports dynamic mapping, which allows fields to be added or documents on the fly during indexing. And we can also have third-party tools like Logstash. So it has a data parsing pipeline tools is often used to conjunction with OpenSearch. So it also has a wide range of plugins for parsing, transforming, and enriching logs. And Logstash can pre-process logs before sending them to OpenSearch. And some other like simple methods that you can follow is like use common schema for logs, or you can use index patterns. So those are the features that we can use for attaining similar patterns with OpenSearch cluster.
Okay, to see how this OpenSearch dynamic mapping and parsing capabilities can streamline the process of handling this job with diverse formats, I think it's making it easier for us to extract the right and meaningful insights from the data.
Yeah, sure. So yeah, these are some of the advantages or some of the capability that we get from OpenSearch itself. So as you can see here, we have several metrics that we have created using the data that we have collected from these IoT devices. So we were able to pinpoint which region has been performing well or which region has been performing bad. And we had a trending chart created with OpenSearch, and we have a histogram with horizontal histograms created like based on the performance of each customers who are logging in. So based on this, we were able to give back a solution that optimized the query performance, and also we were able to like there was a 40% to 50% improvement in customers analytics for and giving back a ready instant decisions during a faulty error for the routers. So these are some of the advantages that we got from this project. And moving on to the case study 2. So this was for insurance company that faced several challenges during their log management system. So basically, they had issues with their account infrastructure. So the main major issue with this customer was their account, like they have multiple AWS accounts within different regions. So they were having issues with managing all these diverse infrastructures, and also they had issues with security tracking challenges and performance issues. So like if you consider all the people who are trying to maintain all this infrastructure, like and monitoring and taking actions based on the data that's coming in, that can be like a too much overhead. So they wanted a solution, and OpenSearch was the solution that we have provided for them. And this is the architecture, high-level architecture that we have created for the customer itself. So as you can see here, we have multiple AWS accounts, and each AWS accounts have AWS Lambdas, which collects data from multiple services. And from there, the data is being collected in an AWS CloudWatch logs, where we use the subscription filters to transform the data. And once the data is being transformed and stored, we have a centralized log repository created in a main AWS account, and we use Kinesis Firehouse to get the data from all these other AWS accounts using a cross-account access. From there, we have a transformation Lambda where we collect these data from the Kinesis Firehouse, and we push the data to the OpenSearch cluster itself. So once we have the data in OpenSearch cluster, we use the data for multiple analytic purposes. We use it for ML analytics, use it for AI, create algorithms, and we have used these for multiple analytic purposes, creating dashboards. And these are some of the major events that we have been doing in our ITTStar company. And the outcome of this was we had a 40% reduction in issue identification, and it reduced the time required for monitoring logs. So, and also based on the data that's coming in, the features that OpenSearch provides, it can handle how much amount of data. So the scalability of the solution was very high. So these are some of the major advantages of creating this solution. And by that, like we can move on to that. Like we have a small demo prepared for this, and let me get that. So as you can see here, this is the Lambda that we use for pulling data from different services that we have in different AWS accounts. And from this Lambda, we get the log data and we try to store it in our CloudWatch log system. And as you can see here, we have our CloudWatch console here. From here, we'll be able to streamline how the data is and how the data is being consolidated. And we can even see the pattern, like how the data is being coming in. And we can specifically go into each day's data and analyze how the data is being pulled. And one of the main features of CloudWatch is the subscription filters. So here, subscription filters are used to filter out the data in a specific pattern that we need, as you can see. So this pattern is specifically for our need, and we pattern it, and then we will push it into our Kinesis Firehouse. And we also have a destination ARN setup within the service where the Firehouse ARNs are being set up, and the data that's being collected is being pushed into the Kinesis Firehouse. And we also have the compression setup, so we don't need to specifically go and manually add it within the console. And once the data is being created and the filters are being done, the data is being pushed into Kinesis Firehouse, and then it's being pushed into the OpenSearch cluster itself. And as you can see here, this is an OpenSearch Firehouse. So here, what we do is we analyze the data volume. So once we analyze the data volume, we will try to split the data into equal parts, and like we'll assign shards so that like how much shards is needed to pull this data in appropriate manner. So once we assign the shards and the data volume based on by analyzing the data volume, we try to set up all the other specification within the Firehouse service. So as you can see here, we have enabled a data transformation where we use a Lambda service, which stream data is being pushed into the OpenSearch cluster. And the data that is being pulled into the service can be tracked using these logs, inbuilt logs. So these can be used to analyze the incoming metrics. And this is a transformation Lambda that we have used to pull the data from the Kinesis warehouse and do transformations and push it into cluster. And this is the UI for OpenSearch. So from here, as you can see, how we set up the OpenSearch cluster with its domain endpoints and the clusters. So as best practice, we always try to create a 3-node cluster where we have like it's a backup and recovery system. Like whenever we load some data, we are able to retain the data using these multiple number of nodes set up. So once the data nodes are being set up and we have backups and recovery set up, we'll also look into the security part where, as you can see, we always maintain a high level security for the data in transit and rest. So we also have fine-grained access controls enabled within the service so that only people who have access can get into the particular data they need. And as this is the OpenSearch cluster configuration, so we have a domain endpoint setup where we use it for accessing the console from having a programmatic access to the console. So if you want to make changes to the cluster itself, you can use this domain endpoint and you can make appropriate changes. And as you can see, the processing status and cluster health, everything can be tracked here. If it's green and if it's active, it says that the cluster is in good health. And once the data is here, you can go to the dashboard where you can analyze all the data that's being collected. So here, if you go to the top left part, like where the 3 lines are, once you click there, you'll get all the options where you can go to discover and analyze your data. So here you can see the number of like how the data is being indexed, and the fields are all to the left, and to the center you can see the overall data like 69,914 hits. So that's the data that's being collected today. So based on that, you can filter out the data based on each day or a weekly basis or monthly basis. So those are some of the features that OpenSearch provides us to play around. And from here, we can use the data for hourly or weekly or like quarterly analysis. One of the main features that OpenSearch provides is the filter mechanism. So you can use field or each fields to filter out the data with specific operators and keywords that we can use to filter out the data that we need based on that particular keyword. So here you can see we have applied an info keyword within the log data, and it was able to filter out the data with only the keyword info. So from there, it's easy for us to analyze the data without going in depth in querying and going in depth analysis with different services. And the other features that OpenSearch provides is vast number of metrics and capabilities that it provides. So here you can use KPI charts, line charts, or we can use histograms to analyze the data that we have. So the main advantage that we get here is you can use data that's coming from different accounts or different services within a particular metric itself. So here we have 2 account data, event and dev. So these data that's coming in can be integrated within the same metric to do comparisons and come to conclusions on the data that's being built. And not only that, we can also filter out the data into single accounts and analyze the services or log data specific to that account. And comparisons, as I mentioned, we can compare the data with multiple accounts. We can do KPI indicators to do predictions, and we can have anomaly detection and different other features enabled here. So this OpenSearch service also provides alerting mechanisms, And we have enabled an alerting mechanism for the CPU utilization. So if it goes beyond a particular threshold, it sends out an email notification with SNS or SS services or email notifications as we specify. And some of the other services that it provides are the anomaly detection mechanism, security analytics, and it also provides a trace analytics where we can use these services in analyzing our data. So this is a small demo that we have prepared for you guys. I hope you guys liked it. And now we can move on to the Q&A sessions. If you have any questions, you can ask now. We'll be able to answer those questions.
Really sounded like a robust solution for the multi-account log analysis. Thank you, George, for giving your demo on sharing your insights on OpenSearch and centralized log analytics. It's time for Q&A now.
Awesome. Thank you, Prithvi. Thank you, George. Hey, before Q&A, real quick, to all the attendees, hope you've gleaned a lot of information so far. Looking forward to the Q&A, but wanted to pop up a quick poll for you guys in terms of the webinar so far. So on your screen, 2 questions gonna pop up very quick to respond to, not too much typing involved. So if you wouldn't mind, go ahead and answer in the questions on that poll before we get to the Q&A. That would be great. Okay, awesome. Great. I think we got the majority of the responses for the poll. So let's go ahead and move on for the Q&A. So Prithvi, George, these questions are for you guys. I've got one here. Okay, are there other approaches or tools that can be considered instead of relying on CloudWatch subscription filters for handling events more effectively for event-driven architectures?
Yes, sure. So we have other services that we can use instead of a CloudWatch subscription filter. So if you are looking for an alternate solution, so there is a AWS Event Bridge itself. So that's like a new release from AWS. So it can be used as a powerful event bus to ingest, filter, and route events from various AWS services or custom sources. So that's like a good solution for like alternative for using instead of using CloudWatch filter itself.
Got it. Thanks. Appreciate it. And again, if you want to hear more about these questions, feel free to ping us or email me or the team. We can happy to go in more in depth here. I've got a second question for you here. I know we're a little bit over time, so maybe this will be our last one for now. Could you highlight the key distinctions between Amazon QuickSight and OpenSearch in terms of their functionality, use cases, strengths? What factors would guide the choice between these 2 tools for specific analytics or visualization needs in a business environment?
Yeah, sure. So these are 2 different tools. They might be similar, but like they have a different realm for data analytics and visualization. So it's all based on the purpose. So QuickSight itself is a managed BI service, and it has ease of use and integration. But it comes to scalability, and if you want to analyze large amounts of data, so it goes to OpenSearch itself. So the ease of use that we can utilize with OpenSearch is high, and the scalability with bulk loading and the integration of AI ML features and the optimized query functionalities that OpenSearch provides is not available in QuickSight. So the best solution is to go with OpenSearch for a large amount of data, and if you have multiple data that you want to analyze within the cluster itself. So yeah, so those are the major differences that you can get through differences between QuickSight and OpenSearch itself.
Awesome. Great. And I know we're 6 minutes over time here, so just want to go ahead and close the Q&A. Wish we had a little bit more time for this, but understood that you guys probably have some other things to do. George, are you trying to chime in?
No, it's Chris here. I have one of the questions. Yes, sorry about that. One of the questions was workshop resources. I'll put in the chat link here. This is AWS Workshop Studio. Yeah. So this is it has all workshops that cover everything. So just when you go to it, you just type in the search box like OpenSearch, and then you'll see when you get there, but like it gives you step-by-step instructions on various use cases from Gen AI to OpenSearch to you name it, Lambda. So this is a really good resource. We use it all the time. A lot of our demos we put in here and we create these workshops. We're looking to grow it even more this year. All the solutions architects around the world, especially around analytics and Gen AI. So check there for those workshop resources. That's honestly the best one.
Awesome. Thank you so much for chiming in there, Chris. And hopefully the viewers stuck around, are still here for that one, for sure. All right, y'all. Thank you so much for your time today. All other Q&A questions, we will definitely respond to one-on-one. We'd also love your feedback. So we're going to be following up with you guys just to see how you enjoyed the webinar, things you liked seeing, things you wish you would have seen. Happy to have one-on-one sessions after this. We are offering for anyone who attended the webinar, if you guys have OpenSearch or analytics challenges going on in your business, we're offering 50 free hours of consulting efforts toward various and sundry AWS projects as a thank you for joining our webinar today. So we'll be emailing you about that and giving you a shout about it. So looking forward to talking to hopefully whoever has some challenges that they might need some expert help with. We'd love to jump in and show you what we can do as an AWS Advanced Consulting Partner. So thanks, everybody. Thank you for being here. Looking forward to our follow-up conversations and hope you found the time valuable. Have a nice day.